Welcome to the first of many videos about SwiftUI. In this video, we're going to build project 1 from Hacking with Swift, called Storm Viewer. You'll see a list of pictures to scroll through, and when you tap on one of those things, you'll see a picture full screen. That's the entire project, nice and easy to get you started. Let's get to it. So in Xcode, go ahead and choose Create a New Xcode Project. Select Single View App under iOS, then press Next. Then I'll call this thing Project 1 SwiftUI. And make sure you check the box Use SwiftUI here. Otherwise, the rest of this tutorial is very confusing indeed. Then press Next and Create on your desktop or wherever you like to put projects. Okay, I'll hide this bar on the left so you can see the right-hand side full screen. Go ahead and press Resume up where it says Automatic Preview, and it'll build our Swift code and show it in a virtual simulator here on the right. And you can see we have Hello World in big text, and that's coming from this body text over here, Hello World. Now, what we want to do is show a variety of items in there using a table view coming down the Y. And in SwiftUI, that's using a component called list. And with a list, you can go ahead and just write lists like that and start adding your items, as many as you want to. Let's just fix the indenting slightly. There we go. As many as you want to. So for example, you might say, I'd like to have many text. So you might say, I want to have text, hello world, and repeat that several times. Let's do 5 of those things. I'll press try again to make it rebuild my code. It'll build, and boom, there's our list right there. You can see it scrolls right to the top, leaving the safe area where this sensor housing is, the notch, free of stuff. Now, of course, you don't want to go right to the edge like that. Normally you want some sort of chrome around it. And in iOS land, that's normally a navigation bar, which in SwiftUI is handled with a navigation view. So we can say around our list, place a navigation view, like that, and indent our list. And with that done, we'll now see a space at the top here where that nav bar can go. We want to give it a title, of course, so it isn't just some big empty white space. And to do that, we want to set a modifier on the list inside, not the navigation view itself, but the thing inside it, which is our list. So for our list, I'd say here, dot navigation bar title, some sort of thing. In our case, I'm going to say a text area called Storm Viewer, the title of our app. It'll think and run it back, and you can see we have Storm Viewer up there in big letters. So we have our navigation bar / navigation controller. We have our table view here full of items, and the static saying hello world again and again and again. And it looks pretty good. And of course you can press, Command R to run the simulator when you need to. But for now, it's good enough to show just that inside this simulator. Now what we want to do is load some pictures into this thing. So when the thing is running, it'll know all the pictures we can show attached to this thing. And right now you can see we have one simple type here called content view. Really what we want is to say, okay, that's our content view, the thing to show on the screen. Separately is a data source containing all our pictures. So it'll have all our data in there to show pictures inside this main list. Now, it just so happens I prepared some pictures for you already. If I close Xcode temporarily, just minimize the window and open up Finder. In this YouTube folder on my desktop, I have a directory here called Project 1 Files. These are taken from the GitHub repository for Hacking with Swift. And you'll see a collection of these NSSL pictures, which is the National Severe Storm Laboratory. And there are lots of these things that you can just go ahead and scroll through. And the pictures are various sort of vicious looking winds and clouds and stuff from the US, like that. And they're all public domain because they're owned by a government agency, so they're good for us to work with. So I want to put these pictures into our project. And when using SwiftUI, it really wants to use asset catalogs. In fact, it's a bit buggy otherwise right now. But for the purpose of this project, I'll show you how to do it without asset catalogs. So if I go to my sidebar here, I can go ahead and just drag in these files. These things here. I'll just drag all this whole Project 1 files folder into my project navigator. And yes, add them to target. Yes, create groups. Yes, copy items. It's fine. Press finish. And see here is all our pictures to work with in Xcode. And then we copy it into our app when it's built. So we can work with those things, which is cool. Now, what we want to do, of course, is show those inside our table view. So folks can see them and work with them using that list there. And of course, we could make an array of hand-typed NSSL 0049, 46, 91, 0045, and so forth. But they're pretty random numbers. You have to type them all by hand, which isn't ideal. So instead, what we're going to do is go ahead and scan through the contents of our project directory and say, find all JPEGs we can get out of that thing and use those if they start with NSSL, the Severe Storm Laboratory stuff. So I'll go ahead and create, outside of our content view, a new class called data source, like that. And for this thing to work as data inside our SwiftUI app, it has to conform to a particular protocol called bindable object. Bindable object. And for that to work, it really only needs to do one thing. It needs to be able to say when this data has changed. Because in theory, you might add and remove items freely, showing more pictures over time as they're added and deleted or modified or whatever. So your data source here, this bindable object, in order to be bound to some sort of UI, in order to be shown as part of that UI, has to know how to send changes to its parent, saying, yep, I've changed. To do that, we're going to use a thing from the combine framework. I'll do import combine. This is also new in iOS 13, and in this case, it lets us work with data by sending changes to somewhere else. We don't really care where, just somewhere else, whoever's watching us basically. So for our data source here, we have combine. I'm going to say our did change property, what we should call when we've changed our data, is what's called a pass-through subject, or we send nothing and never throw errors. So we send void and never throw errors, like that. Make this window slightly bigger. There we go. We never throw errors. Now, the reason we're sending nothing at all is because we don't need to. The thing watching this, bound to this thing, will know to reload our data automatically because it's attached to our data source directly. If you want to say, oh, just send an integer or a string, you'd write int or string there. And similarly, if you could throw errors, if you could say, hey, our picture loading failed, whatever, you wouldn't use never, you'd use some custom type of error there instead. Anyway, good enough for now. We'll then say there is an array of pictures called pictures, which is an array of strings. All these picture image files names it found in the image bundle for our app. When this thing's made, we've got initializer. We're going to say get access to the file manager.default and call that thing FM. This file manager type comes from Foundation and lets us read through, create, delete, modify files on the file system, which is perfect for here. Then we're going to try and read the resource path for our bundle. Cunningly, this thing is optional. We might not have a resource path. This is true, of course, if you're working with, say, a terminal app, which has no idea of bundles, but for iOS, we always have a bundle, but we'll safely unwrap it anyway. We'll say if let path equals bundle.main.resource path. And if that works, we'll then try and read the contents of our resource path. Try and read what's actually there. Now, the way iOS apps work is all the assets you produce, plus your binary, plus any things around it, like a property list, get put into this resource path. So all our pictures would place in this one place called our resource path, which you can now read from. So we can say, first get the resource path like that, then do let items equals try fm.contents of directory at path. In this case, we'll do our resource path. And if both of those succeeded, it means we've got a resource path and we've been able to read the file names from there. We can show them directly inside there, which is great. So we now know here's all the files in our bundle, everything. Which of those are our pictures? Now, if you remember, they all start with NSSL. So we can do a simple scan. Did this thing start with the letters NSSL? If it did, awesome, work with it, add it to our array, we want to use that. Otherwise, ignore it and move on. So we can do a simple loop here. We can say for item in items, if item.has prefix NSSL, great, pictures.append item. So by the end of that loop, when it's gone around all the things, anything that has NSSL at the start of its name will be in our pictures array. That means finally at this point, once the if's finished, we know our pictures array is full of all the pictures for our app. We know we're ready to go work. And so this is when we call did change. we can say, we've finished loading now. Go ahead and send our updates. So we'll write in here, didChange.send. Oops, like that. Send nothing to the thing, void. Now you want to call that repeatedly. Whenever you add pictures or remove them or insert them or move them, whatever you want to do, anytime you want to modify the list of files in the pictures array, you want to call didChange.send. So everyone watching this bindable object knows to reload its data source. I'll press resume to reload the view again. It should look identical, but you get the idea. Have a little think. Boom. So it's the same, because it's still using our static labels down here. Text, 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 right? Of course, what we want to do, really, is show those pictures we just loaded. NSSL00, whatever it was, 39.jpg and similar. We want to load those things. And for that, we want to create a property inside our content view to hold our data source. We're going to say var data source equals a new data source. Create one of these things and assign it to our content view to work with. So we can render it inside there. However, this thing, in your own apps, you might change it. Like I said, you might add things, remove things, insert things, whatever you want to do. You might modify it over time. And the problem is that this thing, our content view, is a struct, which means when it gets recreated, when you've made a change to this somehow, it'll destroy the data source and recreate it every single time, which is deeply inefficient. Now, we're doing a simple directory scan, right? We're not doing a lot of work here, but it's still the risk of it being deeply inefficient for other kinds of UIs. And we don't want that. We want this whole thing to be controlled by SwiftUI. We want it to say, it doesn't matter when our view layout changes, if we modify the way our view looks, the struct changes. When you recreate the struct, don't recreate the data source. Leave that intact. Reuse that. And we do that by saying @object binding. We're saying to SwiftUI, this is still property that I want access to. It's still for me to work with. But I want you to control the memory. You look after storing that somewhere else. So when the view does change, the view is modified, we haven't got to reload it again. Okay. So now we have our data source, and it's ready to be bound to something. By binding, I mean attached to it, like a label. Our list view here, we want to say, show in this list all the items from our data source automatically. As that thing changes, as we call, did send again to add and remove things, update the table to match that as it goes. That's binding in action. So we have binding for our data source, which is great. The next step is to change the way our list works. Because right now, it's completely static. It's 5 static text things, which is not good enough. We want to say, loop over all the items in our pictures array and make cells for those things. Now, to do that, we say list, then open parens, then our data source dot pictures. And it's going to pass in one picture each time. And it's down to us to decide what to do with that. So I'll for now just put in hello world, just for now, just one thing like that. It's down for us to decide how we should respond to that. What do we want inside that list? Now, obviously, we don't want the hello world again. We want something like picture. Give us the picture name instead. So it'll say NSSL0049.jpg rather than hello world. But if I press resume, it'll build around my code. You'll see it's not happy. It's complaining very loudly about building problems. It doesn't understand how to use these pictures. It can't just show pictures like this. It needs more information. And the problem lies right here. When we're giving it an array of something, an array of users, an array of phone numbers, an array of addresses, whatever it is, it's going to create many, many items in our table view. Maybe 10, maybe 1,000, we don't know how many. It'll create as many as it needs from that array of data. What it needs to know is which is which. When we had 5 static text things before, if we removed one of them, it'd go, oh yeah, number 3's disappeared now, I can see that. But now they're being made dynamically. It needs to know how to identify each picture cell inside the main collection. To do that, you can either make your data type conform to identifiable, which is another thing entirely. We'll do that perhaps next week or the week after. Or much more easily in this case, we can say for each picture, identify it by itself. So we have NSL0049JPEG, that's your identifier right there. Use its file name for its identifier. So it can identify them uniquely via its file name. So I'm going to say datasource.pictures.identified by, and it takes a key path, which is going to be \self. So look at itself to understand how to make these rows. So when it comes to what's your identifier, it'll say, oh, I am NSL0049JPEG. And this allows SwiftUI to do much more better animation. It can understand the structure of your layouts more completely. It knows where things are and what they are more completely. So now press try again. And it's going to reload this view on the right using the dynamic data. And now you can see we have 49, 46, 91, 45. It's loaded those pictures correctly. It now knows what they are. And you can see them, they basically match one-to-one with the things over here. 49, 46, 91, so forth. They're appearing in the order they're in that thing right there. So it all works. Great. So we now have a table. And if we had many items here, if we had, 40 pictures, that would scroll. And this nav bar would shrink, just like you expect on iOS. This is a real table view with a real nav controller around it. It looks and works great. Of course, just showing picture names like that isn't terribly interesting. What we want to see is what those pictures actually are. What is NSL0049JPEG? What does that look like? We want to create something we can show. Show me a detail view with that picture inside so we can see it in action. To do that, I'll make another type. And of course, if this were a real project, you'd have multiple Swift files. It wouldn't just be put one big, huge Swift file. You'd have a different Swift file for detail view, different one for the data source and so forth. But, it's a quick video. So I'll say we've got a new view, which is called detail view. And this conforms to the view protocol, which is required to show things on the screen inside SwiftUI. This is going to have a selected image, which is a string. There's a property of the struct. And so when you create the struct, it'll say, okay, what's my selected image? You get the default member-wise initializer built in for you. Now, so what we're going to do now is say, inside our list, where this text thing is here, we want to make a navigation from that list item, that table view cell, into our detail view, showing that selected image. So they'll see a big image each time. And that's surprisingly easy to do. When we conform to this view protocol, we only really have one requirement, which is, what do you want to show? That's it. Because a view shows another view, another view, another view, kind of infinitely, until eventually you hit sort of primitive views like images and labels and similar. So we're going to say in here, what this thing shows, its body, it's called in SwiftUI land, is some sort of view. In our case, it's going to be an image. We can actually ditch the return keyword entirely, sorry. An image with our selected image. Like that. This will be NSL0049JPEG. Make an image out of that and use that for our body. That's the entire thing we're working with here for now. You'll see why it isn't quite right shortly, but that's a step forward. That's the first step. What does our detail view show? The second step is this navigation view we just made. How should it show the detail view? How does it display that in the first place? Well, you can see we have a list of items. That's our table right there. And each one of those has inside it a text component. That's our labels here. What you really want to do is wrap that text component inside a navigation button. Navigation button. And this thing is where you decide how you navigate from A to B. I'm going to choose the first option here, destination. Where do you want to go? In our case, I'll say we want to go to a detail view. Like I said, it has a member-wise initializer. What is the image that should be shown? In our case, that's the one that got passed into our closure here, picture. So I'll just type picture. It asks, is it a detail view or not? Because if you have a split view controller, this matters. I'll say, yes, it is a detail view. Trigger and label don't matter. And what we're going to do is then open a closure inside there and make inside that return our picture. And what that means is this button contains our text. As a result, when I press resume over here and it rebuilds the code, it will understand this whole row here is now tabbable. You can see how there's nice disclosure indicators appearing automatically. It knows there's going to a detail view now, and it shows that text around it. So you can now tap anywhere here to show our detail view. Now, this is just a simulator here. You can press play and it should work. I find it easier when I'm doing playback to make it simpler in my mind to use the simulator for that. So I'll press Command R, and let's see how this thing gets on. Spoiler alert, it's not going to be terribly happy, but that's part of the process, right? So I'll press Command R to launch the simulator over here. That is too big, make it slightly smaller. There we go. There we go, perfect. Okay, so let's try and use it here. So I'll go ahead and press on 46, and you'll see, bang, the app has crashed. And it's playing with lots of things in here. It can't find the image NSSL 0046 JPEG in the main bundle. Now, I've gone through this, I know ahead of time. These files are definitely in there, right? I can go to products here, look at this thing in Finder, dig into it, and you'll see in our resources directory, boom, there are all the files right there. All that's happening is it's an early version of SwiftUI. It isn't able to recognize images that aren't in asset catalogs yet. And now we could, of course, put those in asset catalogs, but our logic actually requires us to scan the resource path for our app. So we can't put it there. So a slight conundrum. Fortunately, helpfully in this case, SwiftUI has an initializer for images that actually uses a UI image. So we can make a UI image using the regular named initializer. That does work just fine with regular images, and then make our SwiftUI image out of that. And hopefully once beta 2, beta 3, whatever it is, 4 lands, this will work correctly. This little shim won't be required. In the meantime, it is required. So in here, you can see I have our image for our selected image. I'm going to replace that with something like this. Let img equals a UI image named selected image. And I'll force unwrap that. I'm happy to force unwrap that here because, well, 2 reasons. Firstly, we have literally just scanned the resource path. We know it's definitely there. So it's safe to load. But second, as you've seen, this thing effectively also is a force unwrap. You know, the built-in SwiftUI image thing, if it fails to find its image, also crashes. So our code is identical to what SwiftUI would have done. Anyway, now for our SwiftUI image, we can now say image, UI image, oops, lowercase, our img. And now we have to use a return keyword. This no longer is a single expression function, or computer property in this case. So that will now wrap our image in a UI image and put that into a SwiftUI image. And that should work significantly better. Still not perfect, but better. Let's try again. I'll choose 49. Boom, there is our picture. You can see it's not great. In fact, it kind of sucks. But at least it's not crashing anymore, right? So it's better in that respect. Okay, let's make this better. So what we're seeing is a very large image, right? It's taking up all the screen. You can see it really does not animate well at all because it's just too big. The pictures are huge, way larger than an iPhone screen. And it's struggling. It can't show that enough in the space we have allocated. So to fix that, we're going to bring this thing down to size. We'll first say, for our image, we'll apply the modifier .resizable. Make this thing be stretchy, so we can change its frame freely. And now when I build and run, I'll choose, was it 49 again? Boom, in it slides. So it's looking better now. We can go in and out freely. Doesn't look quite so bad. I mean, it's warped. It's being stretched to fit the screen. If I can find one that's actually recognizably stretched. That's stretched. There you go. So you can see it's stretched to fit the screen, which isn't great. But at least in concept, it's better than it was, right? It doesn't look completely broken anymore. There we go. So it's better, but it's not great. So after that, once you've got your stretchiness enabled with resizable, you want to tell it the frame to use for the image. Now, realistically, what you want to do is say something like .aspect ratio .fit. Make this thing fit the screen, or make it fill the screen, whatever you want to, right? If I try fit, you'll see this also is struggling right now, and that's fine. That's part of the course, This is beta 1, right? So you can see it's working okay. It's not great, but it's okay. So it's better. What you're seeing is the image is now square. I mean, that's literally a 1-to-1 aspect ratio, which isn't accurate. If I show you the pictures again, this thing here, if it's going to load, Not going to load. Okay, let's try the file inspector. Oh, there we go, finally loaded. There we go. You can see it's 1024768. So it's got a 4:3 aspect ratio. It's not 1:1. And it's a small bug in SwiftUI basically at this point. The aspect ratio fit just does not work correctly, but that's okay. As again, it's a nice little workaround. We can say our aspect ratio will be an exact number. We're going to say it should be 1024 by 768, content mode.fit. Now this is just a simple divisor. This will actually be, 1.3333, whatever it ends up being, right? It's some floating point number. It will actually be 1024 pixels. But it now understands the correct size for the pictures at least. It knows there should be this aspect ratio. So if I press Command R, hopefully now it'll look not stretched and not weird. There we go. That is significantly better. Brilliant. Okay, so now the pictures fit correctly. This is actually kind of coming together. The next thing we're going to do to finish this app off, because it's a very simple app, is show the name of the picture somewhere. I think that's kind of important. So I'll go ahead and find some space under aspect ratio, and I'll say this thing has a navigation bar title with the text of our selected image. Now, by default, that thing will use the iOS 11 style chunky graphics. It'll inherit the chunky style from its parent view controller. So you can see here we have Big Storm Viewer. So when we go into there, we'll see a large NSSL, which might be what you want. I mean, it's not what Apple recommends, but it might be what you want. Realistically, what Apple suggests is those chunky titles should only appear on your first screen. They do occasionally break that, like in Mail, for example, but usually the first screen's chunky, the rest of them are fairly small. And so rather than just doing navigation bar title, text, select image, we want to say text, select image, then, comma, display mode, colon, dot, inline. That gives you the thin style thing. So I'll try again, and hopefully we should see a thinner title. Yeah, look at that. Super nice. Okay, so that's better. The last thing I'm going to do, and this is nice and easy, is to make it so when you tap the image view, it will show or hide the navigation bar. Now, this actually takes a bit of thinking because you've got to try and get into the mindset of SwiftUI, right? You want to try and think how SwiftUI works. Now, you can, of course, just say if your image dot tap action, and tap action, and give this thing some code to run. When this image is tapped, what should we do? Now, inside there, we want to do some sort of code. Image was tapped here, and that'll be run when the image is tapped. Fine, but we can't just declaratively say, show or hide the navigation bar. Because that's now not how SwiftUI works. SwiftUI works much more declaratively. We want to try and do this by giving it all possible states and then allowing it to move between states based on our properties. And so the correct thing to do really here is to add a new variable. So we're going to add a new property here called var hide navigation bar and set that to be false by default. And we're going to flip that to be either true or false. Do we want to hide nav bar or show the nav bar? And we're going to tell SwiftUI to use that thing to update the look and feel of our program. Now again, this thing is going to be changed when our program runs. When our detail view is showing, this value will change, right? And if you remember, this is a struct. Structs don't like to be changed at runtime, they're fixed. And so it's a problem. Swift will not allow you to change this value freely. So what we really want to do again is hand this over to SwiftUI and say, hey SwiftUI, here's some program state that will change while my code is running. I want you to control that for me. And in this case, it's done using the @state keyword, like that, @state. And @state is very, very similar to this @object binding down here. They're the same sort of thing. But @state is used for local things that belong just to your view and nowhere else. As a result, you'll commonly see these things marked as @state private var, like that. It's a private property only available inside this current view. Now, object binding is useful in many places. This @state is used for just this one view. But it's the same thing. It'll exist between states of our detail view. Anyway, now we have that, we can use that single property to describe whether or not we want to show our navigation bar. So below navbar title, I'll say dot navigation bar hidden. And the answer is, should it be hidden or not? I'm going to use hide navigation bar. So when SwiftUI wants to know whether to hide the nav bar or not, all it has to do is look at the value of that property. If that's true, hide the nav bar. If it's false, show the nav bar. And now, in our tap action, we can say self.hideNavigationBar.toggle. So when the image is tapped, toggle that boolean, show or hide the nav bar. So we're never saying now show the nav bar or now hide the nav bar. We're just saying change the state of our program, and SwiftUI will go ahead and recreate the body of our view. It'll run that code again and show or hide the nav bar as a result. I'll press Command R now, and this should actually work. Let's find out. So here's our pictures. I'll choose 46. There's our big one. I'll tap on that, and boom, it shows and hides nav bar correctly. And that's the end of our first project. I hope you can see how easy it is to get started with SwiftUI. If you like this video, hit that like button and don't forget to subscribe to my channel. I'm going to make lots more videos like this one, giving you everything you need to get started with SwiftUI.